John. And also Christian Rodas, one of the senior design, one of the veterans here, a master's student here, who has helped us a lot in giving us some tutorage. But most importantly, we would like to thank Laura Miller for her dedication to not just our team, but all the students for the past year. She has come during our Sunday afternoons for about four hours to give us help and support us. So we really appreciate that, and I hope you'll help me and thank her for just her dedication. Great. Well, good afternoon. We are Patriot Engineering. We pride ourselves in the quality of our work, the innovation of our designs, delivering infrastructure solutions for the improvement of communities and the betterment of the quality of life. My name is Trevor Hughes, and I am the water distribution expert for our team, Patriot Engineering. It is my honor today to introduce my associates, Nguyen, who is our erosion and sediment control specialist, Todd Clifton, land development engineer, Andrew Jink, transportation and project management, Daniel Shirkey, who is our environmental engineer, Diana Villa, our stormwater management specialist, and finally, Erwin Milian, our utilities engineer. Today in this presentation, we will go over first our project task, what our scope of work is. Then we'll get into an executive summary, our zoning and site layout, erosion and sediment control, as well as our grading and earthwork. Then we'll move into our transportation, some of the environmental concerns and design of our site, as well as stormwater management, and finally, we'll wrap up with our utilities design. Patriot Engineering has been tasked by Laura Miller and Associates to work off of a previous preliminary engineering design from DCD Engineering. And off of this design, we were to prepare a final engineering design for Mays Quarter, a planned mixed-use district, or PMD, in which a PMD accommodates both a residential and commercial land use. In the fulfillment of this task, Patriot Engineering has provided 1,385,000 square feet of office space, 171 residential units, at a projected cost of $9.7 million. It is important to note that Patriot Engineering, throughout the design, has been in strict compliance with the standards mandated by Prince William County and the Virginia Department of Transportation. With the environmental concerns outlined in the Chesapeake Bay Preservation Act and the best management practices, we adhere to these throughout the duration and design of our project in order to maintain an environmentally low impact construction site. And it is my honor, I'm pleased to announce to you today that we have achieved LEED Silver for our site today. But where is Mays Quarter? And that was hopefully going to be a rhetorical question, but it seems that you all could tell me where it is as of now. Again, it is outlined here as the star, and this shows you its proximity to DC. Zooming in a little bit more, you can see the proximity of our site here to I-95. And zooming in more, we can see our site outlined here in the green, how it's close to Prince William County through Great Bridge, and then as the lane bordering the west side of our site here. This is a map of the zoning ordinance of Prince William County, and this gives us an idea of what is surrounding Mays Quarter, our site outlined here in green. To the west of our site is zoned in A1 district, and this is agricultural. Directly to the east of our site is a low-dense neighborhood, or zoned R2, R4. And directly surrounding our site is a PMR, a planned mixed residential zoning district. Of course, as I've mentioned before, our site is a PMD, a planned mixed use district, in which we will accommodate R16 high-density, mid-rise residential buildings along with high-rise commercial buildings. To give you a preview of what our design actually entails, here is a site layout of our design, in which we have three distinct sectors: our northern, our middle, and our southern. Here, looking at our office buildings, we have one office building A in our northern portion of our site, and 3 of our 4 office buildings are in the center of our site, B, C, and D. All of our office buildings will be 10 stories high, and you can see here what the total office square foot for each building is. Moving on to our residential buildings, each unit will provide 1,200 square feet per unit, and again, we will have 171 units for the site. We have 2 units, 2 buildings, E and F, in the northern portion of our site that are 4 stories and will accommodate 30 units per building. The rest are in the lower portion of our site here, if you can see that, G, H, and J, which are 4 stories again, and will accommodate 37 residential units. In terms of parking lots, we have 2 parking lots outlined here for our residential use, and we have 3 parking structures to accommodate the high demand, the high amount of traffic we're going to see for our office buildings. Now I'm going to pass the baton off to Kui, who will talk about sediment and control.
Thank you very much. Good afternoon. My name is Nguyen, and my focus on this project is erosion and sediment control. This is a very complex property with a lot of streams and environmentally sensitive areas, or wetlands and steep slopes. So we have to take all of that into account. And our team objective is to, of course, complete the task that we were given, and at the same time be environmentally friendly. So we will save and preserve those stream and wetlands as much as we can. Erosion and sediment control phase 1 is the initial step in the construction process. When we first come into the undeveloped site, this is the map of our existing condition. We have 3 portions of wetlands on site. One is right in the middle, and the other 2 are at the southern corner of the property. This is our limit of disturbance or perimeter control. It was drawn so in accordance to our finished grading plan, but at the same time try to avoid impact to those existing wetlands as much as possible. So as soon as we come in the site, start clearing and chopping down the trees, we have to account for the excess runoff and erosion that we just produced. To catch all the water and sediment from leaving our site, we'll have silt fence running all around the northern half of our site, and then super silt fence on the remaining portion to steep slope and environmentally sensitive areas. We have 9 natural drainage areas outside, in which 5 of them are less than 3 acres. So we need 5 sediment traps and 4 sediment basins to catch all the water and sediment. So 2 out of the 4 sediment basins will be our permanent detention pond. After construction is done, they will be in area 3 and 7. After all the clearing is done, we will come in and take off 1 foot of the topsoil and then dump it into these 2 locations shown in the map. and they will remain there throughout construction phase. They will not have any impact on construction process because those two locations will be proposed parking lot. We have two existing streams on site where we don't have any problem with the lower stream, so we just run a culvert below our street there. But this in the middle one, we run into a problem where we have a sediment trap right here, right in the middle, right in the way of the stream. This is a zooming picture of that section. So we have to design and insert a temporary diversion channel to divert the stream flow away from that trap, and then put super seal fence all around the stream to protect it from sediment and water enter during construction phase. All the diversion channel will be designed in accordance to Virginia Erosion and Sediment Control Handbook. Erosion and sediment phase 2 will begin based on the finished grading plan, and when all the curb and gutter in storm inlet and storm structure have been installed, and with inlet protection and outlet protection. We have 4 areas which gonna run offside. However, the water leaving outside post-development is much less than the water leaving outside pre-development, so it is acceptable. And now I will pass it to Todd Clifton to talk about earthwork.
Earthwork and grading. We have a proposed topography here for the south of Prince William County, and before we start grading, we need to figure out why we're grading it, and what is going to constrain us during our grading process. We have 8 main grading constraints here. We have our site border. All of our grading is going to be done inside of our site border and our boundaries. As you guys have seen, we have a RPA in the southern eastern portion of our site. We will have no grading to be done in that. We will not be disturbing any of the land in the RPA. We have these 2 proposed streams and wetlands that we need to design around to have the least impact on them. Finally, we have our proposed structures. Our grade plan has to be able to accommodate all of these very large buildings, have flat lands for them, and ensure that all of the slopes slope the water away from the buildings. Our proposed roadway will be graded so that it's easily traversable, and that all of the water will be pushed out to our perimeter gutters, will be collected into our detention ponds. For areas where our roadway is not adequate for fire access, we will, in the northern apartment buildings and the southern portion, we'll be grading in flat areas to accommodate fire access and fire vehicles. Those will be grass pavers. And then our detention ponds, we'll be grading in 2 different detention ponds, on 1 and on 2, to be able to accommodate and hold all of our runoff from our site. And of course, finally, be able to have roadways to maintain and access those detention ponds throughout the lifespan of Hughes Quarter. After taking all of our constraints into consideration, we were able to lay down a proposed grading plan, clean it up a little bit, merge everything. We have our final finished grading plan here. And following the Section 300 of Prince William County's Design Construction Standards Manual, all of our roads will be sloped 1 to 6%. All of our pervious areas on our site will have a 3-to-1 slope, and except for one small pinch zone down here where our parking lot comes really close to our RPA to avoid disturbance in the RPA, we actually had to grade that steeper than 3-to-1. However, we are going to put mulch and appropriate vegetation down to eliminate any erosion, sediment wash down into the RPA. And finally, we have a very steep hill on the backside of the lower apartment complex. We have graded in a swell at 3% to divert that water down into the inlet structures. So once all that's done, what does that mean? What exactly are we doing? We are taking out approximately 250 cubic yards of cut and returning approximately 200,000 cubic yards of fill, which leaves us with about 50,000 cubic yards of cut that we will have to truck off of our site, and our cut fill ratio ended up being 1.25. So how do we get all of those values there? On top of our proposed grading plan, we propose to take off 12 inches of topsoil, which we explained we would stockpile and replace 6 inches of that again. We would cut out an additional 12-inch subbase for all of our residential buildings, and an additional 18 inches for all of our office buildings, and cut an extra 10 inches depth for all of our proposed roadways. And we applied a 20% shrinkage factor to that, which gave us all of our, and using computer software, we were able to figure out all the areas, apply our depths of additional cut, and crunch the numbers in that, and output our net 50,000 of cut. I'm going to go ahead and turn it over to Andrew, where he will talk about transportation.
Good afternoon. My name is Andrew Jinks, and my focus for our project was transportation. So with a new development like ours, one that will end up attracting a good amount of people, we had to expect and design for the heavy amount of traffic that would come with that amount of people. It was my job to design a roadway system that could handle this traffic. Here on my first slide is a couple of the steps that I took to do this. First, I calculated the ADT, which is the average daily traffic. This is basically taking the average amount of traffic within a 24-hour period in a given area, and I've calculated that for both the entire site and for each of our 4 main road sections in the development. I also calculated peak hour volume, which is the maximum amount of traffic within 1 hour in a certain section of roadway. Next, we had to figure out the dimensions of the roadway and what kind of road we would use. We would return to the Prince William County DCSM for that Design and Construction Standards Manual, and each of the roadways is based on the ADT and where the road is located and what is it going to be used for. Next is something actually pretty important. That is off-site improvements. Basically what that means is if you have a large site that will end up attracting a decent amount of people, like a lot of traffic, and there's small roadways leading to that site, then those roadways leading to that site will have to be improved. Otherwise, there'll be issues in the intersections along the roadway. There'll be a lot of congestion, a lot of traffic. And finally, to check the entire system, I calculated the level of service, which checks the intersections to see if everything is flowing correctly and if it keep the traffic moving. Here's a picture of our layout, transportation layout. Here in the northern area is going to be entrance A, or street A, which would be our northern entrance. This here will end up being street B, which is going to be our western entrance, and also end up being our main entrance. Street C is our unique part of our project. It was actually in the preliminary design, so we decided that we ended up keeping it, and that is what we nickname as the teardrop roadway, seeing it looks like a teardrop. One thing that we ended up deleting from the preliminary engineering design was a roadway that ran from here down this border down to the residential area down here. We ended up deleting that because we thought that it would end up costing too much money and taking up too much land. So instead, we added roadway D here, which ended up being a much smaller roadway and costing a lot less and taking up much less land. One thing I wanted to point out in the surrounding area is the location of the site compared to the parkway. The site is very near a major road within Prince William County. I'll get into this in a little bit when I talk about off-site improvements, but this is a very important thing to remember. So as I said, our site's going to end up attracting a good amount of traffic. There's going to be about 16,500 vehicle trips per day. 93% of those, 93% of the traffic will point of being office traffic just because of the amount of office space we have. We have a lot of office space compared to just the 7% of residential. Now what this also means is that in the morning, 93% of the traffic is going to be coming into the site, and in the afternoon, 93% of the traffic is going to be exiting the site. So the traffic is very lopsided. 90% are going to use that Street B, the western entrance, because of where it is compared, where the location is compared to the Prince William County Parkway. That means it's going to have the highest peak hour volume and it's going to have the highest ADT. Okay, I actually ended up having to use roundabouts in a couple of areas where traditionally signal lights would be used. I calculated the level of service with a signal light, and it kept receiving a failing level of service. So I checked with roundabouts, and I ended up using roundabouts to help with traffic flow and control delay. And also, it was also a good idea to use roundabouts because there's an existing roundabout around the site, so it won't be too much of a shock to the residents that live in that area. So as I said, the Prince William County Parkway is very close to our site. This here is going to be the main pathway to get to the site. These roads here, Great Bridge and Ashley Lane, are not large enough to handle the traffic that has come with our site. So off-site improvements are going to be needed. This area of Great Bridge is okay, it's 4 lanes, but here it cuts down to 2 lanes. That's going to be expanded to 4 lanes altogether. This existing roundabout that I was talking about before is only a single lane. It's a very small roundabout. That's going to have to be expanded to a dual lane, a 2-lane roundabout, in order to handle the traffic that comes with the site. And finally, Ashley Lane here is just a small rural road that has no traffic lines and is barely 2 lanes. So that's going to definitely have to be expanded in order to handle the traffic that's going to come with the site. So finally, at the end, we were able to calculate the level of service, which gives us a guide on whether all the changes that we made and the intersections within our site are going to be able to handle the traffic that comes with the site. It's just like a normal grading scale, like at school. A is the best, F is failing. All of the level of services that I calculated were based off the control delay. Now, all the intersections within the site and around the site received a level of service A, but not every entry to each of the intersections received a level of service A. The way I calculated level of service basically calculated each lane or each entry to an intersection. For example, if we have a roundabout that's three-sided or 3 legs, maybe one of the sides was B and the other 2 were A. So, which means on average, all the intersections in and around our site end up with an A. Now I'm going to hand it over to Daniel, who's going to talk about parking and environmental issues.
We're going to be talking about parking, lead, and go right into it. In order to meet our parking requirements for the site, we provided 4,584 parking spaces. Most of the parking is needed for the high-rise office use, which requires 4,194 parking spaces. Thus, the relatively few spaces, 390, are used for residential. And following the Americans with Disabilities Act, ADA, we need 83 handicap parking spaces, and 12 of those 83 are required to be van accessible. Now moving on to leadership in energy and environmental design, or LEED. The site needed to be LEED Silver certified, obtaining as many points in the new LEED version 3 system created in 2009. We were responsible for only the credits in the civil engineering new construction department. The only 2 categories available for that were sustainable sites and water efficiency. Sustainable sites has 26 possible credits, and water efficiency has 10 possible credits, giving the total possible credits 36. And in order to achieve LEED certification, 50% of the points needed to be obtained Thus, a minimum of 18 points are needed for LEED Silver certification. In addition to the 36 possible points, there are extra credit points called regional credits that we have obtained. These credits are specific to a site's geographic region and environmental issues according to the United States Green Building Council. They are based on zip code, and for our site it's 22192. There are 6 regional credits available for a normal site, and since we are only doing sustainable sites and water efficiency, there are only 3 regional credits from which to choose from. Now I'm going to talk about the LEED credits that we have obtained. I'm just going to go through a couple of them instead of all this long list. For example, credit 4.2, we provided bicycle racks to 5% of all the building users. And then also for sustainable sites credit 4.3, we provided preferred parking for fuel efficient vehicles. And then moving on to water efficiency, credit 2, we reduced the estimated potable water use by 58%. And then credit 3, we reduced the amount of water, estimated water use by 51%. And then moving on with regional credits, we obtained all 3 of our regional credits, thus giving Patriot Engineering 20 credits, which is enough for LEED Silver certification. Now I'll discuss low impact development facilities. First, we have the use of rain gardens in our parking lot islands, which help reduce the rain runoff and allow storm water to soak into the ground. Next, we used underground cisterns, which collects nearly all the water off every building's roof and parking deck's roof. The water is stored underground until it is needed for irrigation. Next, we provided 29 tree box filters in lieu of the stormwater inlets, which provide some retention capacity for the runoff, but really improve water quality for the VMPs. And then finally, we incorporated the use of 100% recycled plastic benches into the site. Next, Diana is going to talk about stormwater management.
Good afternoon, my name is Diana Villa, and today I'm going to be talking about stormwater management and what we did in order to control the quality and quantity control stormwater from our wastewater. So the first thing that I want to point out is some of the changes that have taken place since the preliminary engineering phase. As it was mentioned by my friend Todd, he said that there was a lot of grading going on in our site after the preliminary phase. So we actually had to go back and reevaluate our stormwater management in order to make sure that we were providing the right control for it. In doing the analysis, we realized that we were producing a lot of steep slopes, and we were going to have a lot of runoff coming into our site from our adjacent areas that we didn't account for in the preliminary stage. So we had to go back and reconsider that. The second thing that we did look into, and it was actually an advantage, is all the land use changes that we did. As Andrew was mentioning before, we did have a really big road going from here to the parking lot down here, and we decided to reconfigure that road for a smaller one. That actually, and some of the areas that were some of the additional areas that we provided open space for the parking lots actually reduced our previous areas. This is showing the existing drainage device. Right now we have several, as it was saying before, we have several drainage devices, but we focus our studies in the 2 main ones. And based on the soil information provided by the previous Milian soil survey, we computed the curve numbers for each watershed. We analyzed the travel path of the flow, and we calculated some concentration at each design point. We got a time concentration of 18 minutes and 20 minutes. For our calculations, we use 20 minutes. The proposed drainage device, this is after we finish our grading and we realize that we are going to have some areas that are going to be draining inside our development. So in pond 1, we're going to have a total of 17 acres draining in, accounting for the 2.2 acres draining from the adjacent area. For pond 2, we're going to have 12 acres draining in, and we also have a couple of uncontrolled areas which we're also taking into account at the time of calculating for quality control and oil area. In the hydrologic study, we used soil conservation service procedures, I believe PR55. We calculated our peak runoff for pre and post development conditions for the 2, 10, and 100-year storms. Based again on the soil conditions and the time concentrations that we found for pre and post development. And we also accounted for 43% impervious conditions post development. The hydrograph that you're looking at is showing it's showing condition for a 2-year storm. As you can see, the blue one represents the pre-development and the red one the post-development. This is a really big change. So what we did is the graph is showing a rough estimate of the minimum storage that we needed to provide for quantity control. We did the same thing for our 10-year storm, and then we came up with the minimum allowable discharge for pre-development, and based on that we provided our storage. This is showing the quality management control that we want to provide. We divided our site into 2 different areas, one impervious and the other one pervious. As you can see, the shaded areas are the pervious areas, which give us 7.79 acres. And taking the percentage of imperviousness, we get 42.48%, which was used to calculate the minimum storage that we needed to provide for quality control. We also have undisturbed areas, which give us a total of 8.7 acres out of the 50 acres that is the total development. And this was later, this is shown in the green, and this was later considered when we were actually going to get our constitution removal. We were required to have a 50% coastal waste removal. Our 2 on-site ponds are going to take care of 40% removal, and the 8.7 acres are going to be granted as conservation easement, so we'll make sure that we get 100% removal for that area. We also can see there, as you can see, the uncontrolled areas, we're showing that we have 0% removal, but we're still over the 50%, as you can see. This is a cross-section of our ponds. Each one showing the elevations of water at different stages, TEPs, 2-year, 10-year, and 100-year storm. And the table on the top is summarizing our information on EMP volumes and withdrawal volume provided based on quality TOs. We also did a channel performance evaluation before we discharged our runoff into the existing wetland and channel. We also accounted for approximately 30 cubes per second of discharge from this wetland, doing again a soil analysis. So according to our computations, this is an example of a cross section of the wetland that is located in the northern part, and roughly we have 2 feet of water elevation. So compared to the channel, we can see that this is an adequate channel to discharge. Right now I'm going to have Erwin talk about utilities.
Good afternoon, everybody. My name is Erwin Milian. My main focus of this project was the utilities that you can see up there. First slide is our existing utilities. What do we have existing? Firstly is our electrical utilities. We do have a little problem where we're going to have to vacate this section up here because we do have a proposed parking deck. Next, on our site, we have our sanitary sewer, which as you can see, it runs right across the middle of our site. And we have one in the southeastern part where the RPA exists. Next up is our our water distribution line, which I don't know, well, it's up here on the north side and down here on the south side. Next up is our proposed utilities. The first chart up here, it shows how long our utilities are in linear feet. We also, our road is a public road, so it does not require easements within the right of way. Next, the easements where they are required are outside the right of way, and this chart tells us what it is. Sanitary is 20, for the rest is 15. First thing up is our sanitary sewer proposed. What you see blinking is what we proposed. They are laid out in accordance with the DCSM of Prince William County. They do meet slope requirements. We do have manholes about 22 at each turn or each junction. Next, we have our water distribution line, and this is what we proposed. We laid them out as well for the DCSM of Prince William County, and they were laid out to meet fire flows. We do have fire hydrants to service both the back and front of our structures. Next up is our electrical. As you can see, what is blinking is what we proposed. They are connected to our structures, and they are connected to our existing electrical utility. Next up is our gas. There isn't existing gas utility, so we proposed it going from the top to the bottom and connected to each structure. We have them brought up to each of our entrances. Same with our communication utility. Same thing, north to south, connected to each structure. We brought them to entrances so franchise utility companies can come and connect with our proposed utilities. Next up, Ms. Villa is going to talk about storm sewer.
There are approximately 135 ducted pipes. They range from 15 to 36 inches, and this is our storm sewer system. We also have a 3-foot culvert that is going to let the water pass from the wetland into the existing channel, and these are shown on ponds 1 and 2. All of our pipes have velocities ranging from 2 to 12 feet per second. So the inlets that we're going to use for our development are standard medium drop inlets and standard curve drop inlets, which were designed in accordance with the Virginia Department of Transportation. Yeah, Trevor's going to talk about water distribution.
Great, thank you, Diana. Using EPA Net2, which is a computer program to analyze the water distribution system on our site, we were able to get our system in compliance with the Prince William County Service Authority standards, in which during our fire flows and peak hour demands, we maintain well above the minimum of 20 psi in our nodes and in our network, as well as we did not exceed the velocity of 10 feet per second in our distribution system. Currently, all throughout our site, we have a 12-inch ductile iron pipe network. Erwin?
On our live guide before our break. First, this is a vegetated area, so we had to, of course, remove all the trees, and they came out to about 375,000. Next, the big chunk of our pie chart, it was our grading, our earthwork, or earth removal, which was about 4.6 million. Next up, our stormwater management, inlet, storm pipes, etc. was about 1.3. Our utilities, what I just talked about, is about 1.6 million. Next up, our site access included roads and curbs, which was about 1.8, which in total came out to about 9.7 million. And now I'm going to hand over the spotlight to Mr. Jink so he can give you his final thoughts.
That concludes Patriot Engineering's presentation of the final design of Bay's Quarter. Thank you for your time.
Okay, we are going to take a 10-minute break, 10 minutes sharp, and very much a stickler.